Hey, good day, future engineers. Let's continue our discussion on the relative motion of particles using translating axis. Now let's proceed with our second problem. So here we have a plane A and a plane B. We have two planes here. One is traveling along a straight path. The other is along a circular path or a curvilinear path. So we have, let's read our problem. We have plane A flying a straight line path, whereas plane B is flying along a circular path having a radius of curvature equal to 400 kilometers. Determine the velocity and acceleration of B as measured by the pilot of A. So let's write our one. So we have here, this is the velocity of the A. The velocity of the A is equal to 700 kilometers per hour. The acceleration of the A is 50 kilometers per square hour. The velocity of the B at this specific instant, or that is since the plane B is moving in a circular path, therefore this velocity, as you can see in the picture here, is the tangential velocity of the B, which is equal to 600 kilometers per hour. And its acceleration, or the tangential acceleration at that point, is equal to a negative 100 kilometers per square hour, or you just represent this with like this, downwards. Just have another item. Here we have a given 400 kilometer radius sa ang plane B. Now we're asked to find what? We're asked to find the velocity and acceleration of B as measured by the pilot of A. So sa na siya, is it the relative velocity of B with respect to A, or the relative velocity of A with respect to B? Now, ingon niya diba as measured by the pilot of A. B as measured by the pilot of A. Therefore, our translating axis should be at A. Then, therefore, we'll be using this relative. We're asked to find this relative velocity of the B with respect to A. Okay, since okay, so let's start first with the velocity. So the velocity, absolute velocity of the B is equal to the absolute velocity of the A plus the relative velocity of the B with respect to A. From this one, we can just use directly the scalar analysis because at this specific instant, there are only velocities along the y-axis in this graph. So you have the velocity of the B. So the velocity along the curvilinear path is always tangent to its path. So we just have the positive 600 kilometers per hour, and then the velocity of the A is 700 kilometers per hour. Then the relative velocity of the B with respect to A, as measured by the pilot of A, is just equal to what? Negative 100 kilometers per hour, or simply 100 kilometers per hour downward. So this is the magnitude of the velocity at B. Its direction, the direction of the velocity of B with respect to A, since there are no other components, there is no an x component, only y component, then therefore it is just 90 degrees downward. How about with the acceleration? And with the acceleration, we can try to consider using the vector analysis. Why? Because the acceleration of our plane B, since this is moving in a circular path, it has a tangential and a normal component of the acceleration. You're already given with the tangential component, then we need to find the normal component of the acceleration of the B. So its normal component is just equal to the square of its tangential velocity over the radius of curvature. So the square of its velocity, we have a 600 squared over 400. Then we arrive at 900, 900 kilometers per square hour. So that is towards that direction. So the acceleration of the B, so we have a 900 I hat, and then we have negative 100 J hat. Is equal to the acceleration of the A is just forward. We have a 50 I hat plus the relative velocity of the B with respect to A. So the relative velocity of the B with respect to A, we just simplify this one, combine like terms. Then we have a 900 I hat minus 150 J hat kilometers per square hour. Since we're asked to find the magnitude of the acceleration of the relative acceleration of B with respect to A, we just square those components. Then we'll arrive at that the magnitude of the acceleration, relative acceleration of B with respect to A at this specific instant is equal to 912.41 kilometers per square hour. How about its direction of the relative velocity of B with respect to A? So if you just graph note that the x and y component of the acceleration, we have here we have the 900 here, kilometers per square hour. And then in naog siya you have a 150 kilometers per square hour. So we need to find this theta. So that theta is just equal to the tangent inverse of 150 over 900. And that is just equal to 9.46 degrees. And will be the direction of the magnitude of the acceleration. Relative acceleration of B with respect to A.